Okay, let's give you guys some examples of a case where you have infinity over infinity. So what is the limit of this as x tends towards infinity? So as x tends towards infinity, this thing here is going to head towards infinity. As x tends towards infinity, this thing here is going to tend towards infinity. So here you've got a case where you have infinity over infinity. Well, remember, infinity over infinity, you can apply L'Hopital's rule. 0 over 0, you can still apply L'Hopital's rule. So here we've got infinity over infinity, so we can apply L'Hopital's rule. So remember, L'Hopital's rule, you differentiate this, that will then give you this, and then differentiate this, that will then give you this. Now check. So as x tends towards infinity, as x tends towards infinity, this thing is going towards infinity. As x tends towards infinity, then this thing here also happens to head towards infinity. So now we've got another case of infinity over infinity. Because we've got a case of infinity over infinity, we can apply L'Hopital's rule again. So applying the rule again, so differentiate this, that will then give you this, and then differentiate this, that will then give you this. And each time you do it, you have to check. Check now. Now check. So as x tends towards infinity, this thing here is heading towards infinity. As x tends towards infinity, this thing here is also heading towards infinity. So now we've got another case of infinity over infinity. If we have a case of infinity over infinity, then we can apply L'Hopital's rule again. So differentiate this, that will then give you this. Differentiate this, that will then give you this. Now, as x tends towards infinity, this thing here, well, it's going to be 6, but then this thing here will be a massive number as x tends towards infinity. So if you have a definite number over something very, 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 very big, then you can say that this is heading towards 0. So the limit of this will be 0, because this is a definite number. This number here is going to be very, 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 very big. So overall, it will head towards 0. Okay. So something to consider. Earlier, I gave you I think x to the power 3 over ex, and then this here would tend towards 0 as x tends towards infinity. What happens if we change it to x to the power 7, or x to the power of 73, or x to the power of 739, say? What would be the limit of this? Well, if you think about it, here you've got infinity over infinity. Well, if you apply L'Hopital's rule here, so if you differentiate this, you're going to get something like this, but then this stays the same. This stays the same, and then here you've got infinity over infinity again. So you apply L'Hopital's rule again, and then can you see this thing here is getting smaller and smaller each time, but the denominator stays the same. So eventually you're going to get to a definite number, and then this thing here it remains the same. So you're going to get a number over e to the power of this thing, the limit as x tends to infinity. So no matter what power you have, you're always going to end, if you keep on applying L'Hopital's rule here, eventually you're going to get to a definite number over e to the power of x, and then you can conclude that it's going to head towards 0. So no matter what power you have, x to the power of 7,200,000 blah blah blah, let's say 700 here, it will head towards 0, because if you think about it, if this thing here climbs a lot faster than whatever power you have here, because this thing here climbs a lot faster than whatever power you've got, then you can say the limit will head towards 0 as x tends towards infinity. Okay, so as it turns out, no matter what power you have here, this will climb a lot faster than whatever power you have here. Okay.